Then hi and welcome to this session on how to be more productive as a developer, how to build more productive development workflows. And I'm hoping this is going to be a fun session with a lot of live coding and live demos, because I think that's the most fun thing to watch. So I'm very happy to be here and to be back at Øredev. My name is Sebastian, born and raised in Munich, Germany. And I do a lot of, Java stuff, and I mostly work in enterprise software. But this topic is, in general, how to be more productive on the development workflow side. But I will show most examples, or all examples, actually in Java, in enterprise Java technology. But just that's the most important takeaway, that is actually applicable for all kinds of technologies. So the approaches and concepts I'm going to show you are somewhat generic, and you can apply them as a software developer in general. So just because I'm curious, who of you is actually working with Java or as a Java developer? Hands up. Okay, almost everybody of you. Okay, awesome. So this is about, how to be more productive. And let's just start right away. What I'm going to show you is this. I'm going to show you a project, of course, Hello World project, right? Most simple thing. And it's actually not about the project at all. It's about the workflow, how we build and ship that software, right? So this is obviously a Maven POM.xml. Who of you has used Maven to build their stuff? Right, okay, most of you. So that is just an XML descriptor of using, I use typically Java EE or Jakarta EE that comes from the EE background with, there's a thing called microprofile. I don't know, who of you has used EE technology or is using that? Java EE, okay. Who of you is using Spring? Okay, it's very similar in that regard, but it's much more about, how to build these projects. And then, of course, what I'm going to do, I'm going to build a Hello World example. So this is using JAX-RS. JAX-RS is a standard for building RESTful web services. What I'm going to write real quick is, of course, a Hello World application, an application that says hello over HTTP. So I'm going to have an HTTP endpoint, and then I'm going to show you how to build and ship that application. And then, how to optimize that workflow, right? So I'm going to show you what is a typical workflow that we see in projects, and then, how to advance from there. So what I'm going to show you is I'm going to code a resource. It's going to be a JAX REST resource, like a REST resource that is available under the path HTTP, / greetings. So it's going to saying hello. We're going to have a path HTTP get, for example, greetings, and then / something else. For example, I can write a method that says hello, right? Exciting, I know. And for example, we can have a subpath / greetings / hello, right? And with an HTTP GET request, we're going to execute that method. If you're familiar with the Spring syntax, this is very similar to Spring REST controllers, right? You just have slightly different annotations, but that's pretty much it. So we're going to say hello, and of course you wouldn't execute the business logic right here away in the resource, but instead what you would do, you would inject another component, right? You would use another, what is called bean in the Java world. For example, let's call a bean that is simply called hello. That will be the typical, the entry of your business use case where you call this sophisticated hello algorithm. So we're going to use this. We're going to just say, we have a class here that we create, and that simply says hello. Yeah, hello. And that's pretty much about it, right? And then we can implement this here, and so on and so forth. So now the question is, how do we actually roll this out? We can make this, for example, an application scope CDI bean. So I'm going to use CDI with JAX-RS, so I can inject this, and so on and so forth. You can also, just because we can write a second method, so it's even more interesting, hello and hi, right? And then we have two different responses. Something like this. Now the question is, how do we ship this, right? What do we have to do in order to have some running example? And first of all, I want to test this, right? I want to see whether that works as expected. So either I could write, some unit test or some integration test, but first of all, I just want to run this. I want to see whether that works. And in order to do that, I have to build the project, right? That's the most basic thing. I have to compile and package the sources. So typically, I could use the Java compiler, but typically we use a build tool for that, right? Maven, for example. So I go to the command line or within my IDE, whatever you prefer, and I say things like, Maven clean install. Or we could actually optimize this more. We don't have to install that to the local repository. We can say Maven clean package. Or even, if you know about the Maven phases, you could get rid of the clean phase, just say, okay, just package this. And then if you know about the Maven phases, how they work, there are different goals that are executed, and with Maven package, or let's just call Maven clean package, that will be that will clean the project, and then we'll compile the sources, compile the test sources if I have some, execute the test, and so on and so forth. You see the different plugins that are called here, and that is already kind of important, because what we want to make sure that this build runs real quick. So this is now 3 seconds. Probably my laptop is a little bit slow. That should actually run in 1 or 2 seconds. That would be an appropriate build time. How long does your Maven builds take? More than 3 seconds? Probably. I mean, you probably have a few more classes there. But, well, we're going to talk a little bit about that, especially about test runtimes, because that's typically the slowest thing in your pipeline. But now, what do we achieve? We compile the sources, and we have something like an executable binary in a Java world, right? Like a jar or a WAR file that we can, well, deploy. So in this case, what I'm going to do, and there's a reason for that, I'm going to talk about that a little bit more later. I have what is called thin WAR file, a thin deployment artifact that literally only contains the classes that I have in my project. And then what I need, obviously, is some kind of runtime. In Enterprise Java, we had something, the scary word application server, or you just call them runtime or whatever. In this case, what I'm going to do, I use Docker to run and ship my software. Who of you uses Docker? Hands up. Okay, most of you. So you might be familiar with that. That is a Docker file. And this Docker file just tells me, well, that's already a good thing. What do I have here? I have a what is called infrastructure as code definition, how my runtime looks like, right? So instead of going and manually downloading some stuff like, the runtime, like Java, like configuration, I tell as code all of the steps that are required in order to run my software, right? So I might have something like a base image that already includes, in my case, an OpenLiberty server that has Java 12 installed. By the way, just because I'm brave, I'm using Java 12. Who of you uses Java 12 in production? Nice. Who of you uses Java 13, by the way? Nobody? Oh, great. Okay, who of you uses Java 9, 10, or 11? Okay, that's good, that's good. And the rest, I guess, Java 8? Yeah, well. Anyway, you can try that out already, the newer version. And then what I specify here is just some optional server configuration and, of course, my deployment artifact. And that is already quite important. Why? Well, if I build now my Docker image, for example, I say, well, build something like hello, then this builds really, really fast. Why does it build really fast? So that is already an important thing. My Docker image itself, the whole image, is actually quite big. It has like hundreds of megabytes because it includes a whole application runtime, the JDK, which is quite big. But it's still fast to build. Why? Because, well, of the way how Docker works, of a so-called copy and write file system. So it actually only does changes, a little bit like Git, if I have some actual changes. So it only actually adds what changes in the image, and if the individual layers, the individual steps that I add, for example, I add a file here, I add a file there, are small, then these changes will be executed very quickly. So in my case, that means my WAR file is actually tiny, only has 5 kilobytes, and this is why it actually is being added very, very quickly. So anyway, now I built this into a Docker image. Now, finally, in order to test my Hello World example, what can I do? I can run this locally, right? That's the beauty of these Docker approaches. I can actually run in the same way like I would later on run in production, test my software locally on my laptop. So I do things like Docker run with a port 9080, that's the default port of Liberty. Please run this image, I think I called it hello temp, right? Run this locally, and then what it does, of course, it starts up my server. And then I can go to a browser and say, okay, point it now to this local host URL, or of course do this, using HTTP PI or curl to get curl localhost, and then whatever. My application is called hello. That is because of the war file, and then I think I called this greetings, hello, right? Yes. Okay. Hello world example works. Exciting, I know. I can even call hi, right? And it will say hi. Great. Isn't software amazing? Okay, now the point is, how did we get there? We had to build a Maven build. We had to issue the Docker build, the Docker image build, and then the Docker image run. Now, the point is actually not whether it says hello or hi. The point is about the development workflow. So what do I need to do as a developer in order to test my software, right? Or in order to even just see this example running locally. So for example, if I were about to change, hello to something else, let's say hello exclamation mark, then if I call hello here, well, then obviously it's not going to change, because that still runs my Docker container. The Docker container is a locally running process that still has, the previously compiled class file. So there's no connection. So in order to see that change, what do I have to do? Well, of course, I need to first of all rebuild my project, right? Maven clean package or Maven package. Then wait 2-3 seconds, okay, and then I can say, please build the Docker build. That is at least fast enough, and then the Docker run. That still needs a few seconds until my application server is up and running. And then finally, I can have a look whether that is now being deployed and call the hello method, and then I see the hello exclamation mark. Okay. You would say, well, with such a modern approach, modern runtime and kind of small application, that's still doable. But I would say no, it's too slow, takes too long. And also I had to issue a few commands, right? So first of all, what I could do, I could optimize this. What should we always do as developers? Automate, right? Automate stuff. That's what the computer is built for. I don't want to issue things, manually. So the first thing I could do, I could create a script like, build, run, something like this, and then say, well, what do I need to perform in order to, no, my shell aliases don't work, in order to build and run my software? Well, all the steps I just did manually, right? I could say Maven clean package, Docker build, hello, and then Docker run, right? And I could include some other things, for example, Docker push, deploy this somewhere, go to Kubernetes and deploy it there if you want to. And I think that works. And then at least I already have some improvement. I can run this example, and then I can go and make some coffee or drink some coffee and just wait for it, talk to colleagues. Oh, still not gone. Okay, check social media, check emails, check Slack, right? And this is the problem here. Because what happens, you get distracted, right? So you just are out of that flow experience of developing, and then you're somewhere else, you check your emails, and then you totally, first of all, forgot what you wanted to do. It's annoying to wait, because you don't get that immediate feedback loop, which is the nice thing about flow activities. And you always just have to wait, even if it's, what was it in total, I don't know, 10 seconds, which is really, really good, modern technology, but 10 seconds, which is not instant. That's just too slow. And that is the whole point of whatever you're doing while you are in this, I want to work now, while you are in this development mode, it needs to execute quickly. You want to have that quick and short feedback loop. That's crucial. So in this case, well, this doesn't work like that. Let's stop it here. And now there are many, many approaches to make this a little bit faster. What I will show you, because I use this OpenLiberty server, is there is a Maven plugin available. And typically, I say this with caution, typically I'm not a big fan of putting a lot of stuff in your Maven pipeline or your Maven build cycle, because what happens, most of all, it gets slow, right? Your Maven build becomes slow, it executes 20 phases and 3 different profiles, and then you have to wait half a minute and not just 3 seconds for your Maven build. In this case, what I'm going to execute here has a nice killer feature. It has a development mode. So what I can actually run is this liberty:dev phase here. And again, this is now very specific to enterprise Java. But the point what I want to show is to run something in a runtime, in a hot deployment mode, where I can actually make changes and see the changes immediately. Why? Because this mode, what it does, it actually listens to the source files you have and source file changes, and then it will automatically apply these changes. And in this case, it knows about the runtime. It will even compile individual classes and swap them. So in this case, once that is up and running, I can see hello, okay, Now, same thing as I had before, it just says hello. That is still my runtime running here. But now the good thing is, if I actually now change hello to hello question mark, then what it will do, it will immediately compile the changes, swap the application in less than a second, and I can see the changes right away. So I can change hello to hello exclamation mark, change that back here, and then there are my changes being applied locally. Which is much nicer, because then I don't have to wait 10 seconds, I don't check social media, I don't get distracted, I don't update Slack, but I can just continue working, right? I don't even have time to grab my coffee, I just continue working, which is already very, very helpful. So that's actually the most important thing here, that I have some runtime that runs in a mode where I can just immediately see my changes being reflected. Now, this approach, that is a very simple change for just a Java constant, just a string constant, but it actually works for many, many things. I can add a new class, for example. I can say, well, here's my hello application, hello, hi. Let's add another method just because we can. So you see, this is not just for simple examples, but for example, if I say greeting, goodbye, right? So there are a lot of compilation errors now. So the tool will continuously try to recompile, doesn't work, okay, try again, recompile, doesn't work. But I don't have to care, I just continue coding, right? In the meantime, I will just have have a lot of errors here. Well, not yet. Well, now it doesn't have an error anymore. Goodbye. But once that compiles and it's there and up and running, I can actually see, okay, my hello does work. And I can go to goodbye, and that also is a new path, right? So I can actually add some Java classes, I can do whatever I like, it will just continuously recheck this. Okay, so that's one thing. But then of course, I can change and manually verify things that I do on a manual test, but that is not what we should do in software development, right? We should have some automation to have some proper tests, right? Because otherwise I don't want to issue curl each and every time I want to check something here. So of course what you should do is to have some proper tests. So let's include this. And that is already a very important thing about the test life cycles and the efficiency of the test cycles you write, because typically they're just too slow. So what I usually show is something very, very boring, and I know this is boring, but I still show it on purpose. Why? Because it's somewhat counterintuitive, at least what I see in projects. So this is supposed to be a very simple unit test, where I unit test what my hello class does. If I say assert that hello, that is assert j with junit, is equal to, well, hello. I know. Super exciting. But that is already the point. I want to make my tests, my unit tests, as simple as possible. Why? Because in this case, what I get here, this is just a very simple unit test that executes my business logic, my hello or my hi. But the point is, the tests run quickly, right? Because in a lot of test life cycles that you have, if you have, well, it doesn't run quickly if the IDE is still sleeping. But the test life cycles you have, if you build a lot of code level integration tests, in Java Enterprise you have things like Achillean, Spring context tests, CDI unit, so test runners that just build up the whole world and start up your application in a simulated environment, that takes 5 seconds, 10 seconds to then execute the test. That is again too slow, right? Because you want to run a test, and the test doesn't run in 2 milliseconds, what we have here, but in actually 5 seconds or 10 seconds, that is just too slow to wait for it, right? So for everything that you test that can be tested on a code level, testing only business logic, you should write them in a way that they execute quickly, which is just using a plain test technology such as JUnit or TestNG without a lot of magic, without a lot of reflection or test runners, to have quicker life cycles, which is maybe a little bit counterintuitive. So in this case, what you can do, either you run your tests in the IDE, what I just did, or this plugin can actually also run your tests if you just hit enter, and then very quickly, you can verify and rerun your tests. It will also, we have it somewhere up here, compile your unit tests somewhere. So if you write, you test new tests, what I just did, it will re-execute them as well, right? So for example, now talking about this, developer experience again, if I change some code here, and if I say, oh great, I just go here and execute my test, then really quickly, I want to have the result whether it works or not, right? That was less than a second or whatever. So I immediately want to stay in that quick feedback loop as a developer, to stay in my flow experience, to see I changed something here. I can already verify that on a code level, right, by using my unit test suite, and I just run this, and I don't want to wait 10 seconds again, because then I get distracted, smartphone, Slack, right? But I want that feedback immediately. And now let's change this back. And the same is actually true if I want to test that on an end-to-end level, what I had before, right? So before I was changing some code, and thanks to this plugin, it changed on my locally running runtime real quick. But then, well, how do I verify it properly? I don't want to reissue curl the whole time if I have, something more sophisticated, like I order a new customer, I put in some, more complex process, but then I want, some more complex end-to-end integration test. So let's write something that is called IT. That's a Maven convention for integration test. So per default, if you write these tests, and that is nothing new, that has been around for ages, it doesn't actually execute your tests if you run them in a normal Maven default scope. Let's go into this this project and say, if, for example, I say Maven verify or Maven package, it doesn't actually run this hello IT. It only runs my tests, which are still, 2 tests cases, only the hello test, not the IT. Why? That is executed by another phase, which is called failsafe integration test. Again, that's a Maven convention. I don't have to configure anything here, and that runs my IT, which of course is green because I didn't actually test anything. But that is already interesting, because then I can have 2 different test phases out of the box. And in this case, what I want to do, I actually want to go to the deployed application, locally deployed application, and end-to-end test it in the same way, like, or a similar way like you would production test your application, like a user would access the application. So I use the same HTTP interfaces, for example, right? Or I use the same website, I use the same messaging endpoints, things like that. So in this case, I prepared something just to make that quicker. I have something like a HTTP client that does that on a testing, on a test scope, which is called Hello System. That is, by the way, a good recommendation. Where's my test? To write more maintainable tests, to split up the logic of what I want to test to the implementation what I want to test. Private final Hello System. So I can instantiate, not null, but new hello system. And I can say, hello system, please, get the greeting for a specific message, for example, hello. And now assert that, so this basically goes to, greeting hello. And now assert that this is equal to, well, my hello message, right? Is equal to hello. And what this will do, this will actually go to the deployed system and verify whether, my HTTP endpoint says hello. So what happens here if a test, by the way, if a test is only green and you only saw the test being green, don't trust that test. Right? Because what does it mean? Either you did everything right and your test perfectly works the first time, or your test sucks and you don't even know because it's just green. It doesn't verify enough, right? So what helps is purposely make that test fail and then see whether it's actually being read, like right now, and you says, oh, it's supposed to be hello exclamation mark, but actually it's hello, and then you can change it back. And the same thing you can test, of course, using this other approach, and now it will run your hello IT, and that will execute that test as well. Now, what is the interesting thing about that? It's this lifecycle that you build up that you actually can very quickly verify something on an end-to-end level, right? Because that is using the same interfaces that your client would use. It also uses internally. It does an HTTP call, HTTP get to whatever /hello /greetings /hello in this case, and then it verifies whether that is 200 okay and whether that gives you, the hello string, right, as you saw in the test case. So in this case, I can build up another test to say, hello system, what else do we have? Get config. There is even a config resource, which has some configuration here. curl hello/config gives us hey. Okay, let's test this again. So then we can real quick write another test config for this, for example, and that says is equal to, well, hello, this test now should fail, right? Because that should be equal to hey, and things like that. So basically, we stay in that productive workflow of saying, okay, we want to change things, we want to change a test, we create new logic, then we immediately create an end-to-end test to test that logic, and the point is we always have a very quick feedback loop. So we always immediately can say, oh, please execute the test, and now they're green again, because immediately we see that change here. So if I change hello to something else, and then I rerun my tests, well, first of all, the unit test will fail. That's already a good thing. So in this case, my hello test will now fail, and I say, okay, that is actually expected, so I want the hello exclamation mark here as well. And then I can rerun this again, and then my IT, my integration test, my end-to-end test will fail of saying, okay, on the unit test level, everything's okay, but now I went to the actual deployed application and verified that, and then you see whether this is okay on that level as well. And then you can go and advance further, because then you're already quite certain that everything works as expected, right? So basically what you're trying to build up is a local development experience that just gives you much quicker feedback whether things works as expected, whether your code works or not, and you can just stay in that development workflow much longer. Now, of course, this is somewhat a very quick workaround to the typical way how we would deploy software, which is using a proper CI/CD approach, right? A continuous integration pipeline. So why is this the case? And this is now on purpose, and this does not quite even contradict this approach. Because what we have, I showed you Maven to build the project, I showed you Docker already. Who of you is using container orchestration, such as Kubernetes? Okay, I'm going to show you this in a second as well. So with Kubernetes, what does it do? Well, it basically orchestrates these Docker containers that are now started up locally, right? But on your production environment, you probably don't do a Docker run on some laptop, right? You probably have some more servers there, and then you need to orchestrate and somewhat put your applications there and distribute them on multiple machines, and then load balance them and have some networking and proper approaches, which is then done by that technology. You can even run Kubernetes locally, also might make sense depending on what you want to test. But the point is, the more of these cloud native technology we add, the more complex and long running our workflow becomes, right? Because if you do a Kubernetes test locally, then you have to do even more steps, right? In order to see some changes, you have to compile your software, you have to package it, you have to build a Docker image, you have to update your YAML files, right, for Kubernetes. You have to do a kubectl apply and apply this to Kubernetes, right, and then wait until that pod is being started up. And then after 2 minutes, a few coffee and some Slack messages and social media later, you ultimately see the changes being there, right? So that is the point. While you are in this development workflow, you want that experience just to be quicker. Now, what I showed you here was locally running Docker containers with some approach using enterprise Java. But that also works if you are in a cloud environment and if for some reason you have to test in a cloud environment. So for example, I asked about Kubernetes, so probably you've seen about such things before, right? Who of you knows this YAML file format? Who of you likes the YAML file format? Hands up. Oh, nobody. I wonder why. So anyway, that is a description of these Kubernetes resources, which talks about what is a service. A service is basically a load balancing mechanism, an abstraction over an application like Hello World. A deployment is basically deploying my application in so and so many replica and so many instances. So this is gonna create one atomic workload of my application. I could change this to 2 or 3 or whatever. And then that is running my software on an environment. So, for example, I have a Kubernetes cluster running. Actually, not on my laptop. I could run this there, but this runs in a real cloud environment. I use the IBM managed cloud service for Kubernetes. You can use any managed cloud, or build up your own Kubernetes cluster if you like. But what I can do is basically say kubectl apply, this breaks a little bit weirdly, to apply, these files, like my hello world YAML file, to my cluster. And then it will create, oh god, I hope the Wi-Fi works. Then it will create a few resources there. And in this case, what it will do, ultimately I will end up with what is called pod, that is basically an abstraction over a running container. So I have my hello world application running in one instance here, and then what I can do is, well, I can access my cluster. Now it's not localhost because it's actually running somewhere in the cloud. So I'm running some magic script to get the IP cluster of my cloud. Come on. In case the Wi-Fi works, yep. And then it says hello, greetings, hello, right? This is what we're used to. And then this will say, oh, hello. Great, right? Because it actually runs the image, the Docker image, in my cloud setting. Now the point here is, that is great. Assuming this is a staging environment or a test environment I can use as a developer. And assuming I want to test now stuff there. What do I have to do? Well, the point is, how do we execute and deploy our software there? Hopefully, ideally, we have a proper CI/CD approach, right? That means I store all my artifacts under version control in Git. Then I would do, I change some code. I do a Git push, and then my CI/CD server wakes up and builds the whole thing for me. It will do a Maven compilation, Maven package. It will do the Docker build, either using Docker, using Scaffold, using some other technology. It doesn't matter. It will create a Docker image. Then it will, take these YAML files, update them to the current image that just have been built using the pipeline, right? And we'll deploy them to this environment in the same way that I just did locally, like kubectl apply or something like that. Now, that first of all takes long, right? Because the CI/CD server will run even slower than my laptop a little bit. So I had to wait probably like 5 minutes. How long does your CI/CD pipeline, if you have one, hopefully, run? More than 5 minutes? Oh god. More than 10 minutes? More than 20 minutes? Oh god, let's stop here. Okay. Too long, right? Because in 20 minutes you get a lot of distraction, right? A lot of Slack messages, a lot of social media. So if for some reason, let's say you're testing the authentication integration in your cloud, or you're testing another service that is only available in that cloud staging test setup, then what you have to do, you always have to change your code, put in some debug information. Let's say you don't know what is happening right now. You're going to push that and then wait 20 minutes until that is being deployed. That is one thing that is super inefficient. And the second thing that's even worse, your colleague who's sitting next to you is getting all of these emails and notifications of your failed builds because it doesn't work again, it doesn't work again, you did another git push, it doesn't work again, and at some point your colleague would be, Sebastian, by the way, what are you doing? First of all, you're annoying me with all these notifications, and can't you use your stuff correctly? Why is all of your stuff failing, right? So it's really embarrassing. It doesn't really look good, right? And of course, you're distracting a lot of people because then the build is failing. They have to look, oh, who was it that the build is failing? Was it my fault? And you're just wasting a lot of time. So in this case, even for that cloud scenario, there are some resources available. There's actually a video on this Liberty plugin. So one thing I want to show you, and again, that's just one example. This is called Telepresence, which is a tool specifically for Kubernetes, where I can go to some Kubernetes cluster, like the one I have, and, well, for testing and debug purposes, putting in a proxy connection to actually, for example, my local laptop. So what I can do, I can forward things that run somewhere, for example, in my local environment, because my local host here is still running, right? That still runs this plugin. And I can go and say, okay, now I have my application running in my Kubernetes cluster. And that, in case the Wi-Fi works, will give me the Hello World application, right? The thing that is running. And now what I can do, I can say, oh, Telepresence, please swap this deployment. That has been created by a deployment that is called Hello World. And what it will do, it will swap it to whatever it runs locally on my laptop with port 9080. Why? So what is going to happen? This is actually going to insert a bidirectional proxy into the cluster. And then for the testing purposes, it will forward all of the traffic to my little laptop. So for sort of, my laptop becomes kind of part of that Kubernetes cluster for these testing purposes. So the laptop can then access other services and other resources that run in that test staging environment. So what happens then is that once this is up and running, this now starts up this proxy. I can actually have a look at that. My pods that run in my cluster will then be replaced with another pod that just has been started up. That is basically a proxy named similarly. But then let's wait for this to fully start up. Then what happens, this is going to forward all of the traffic that comes in using the proper cluster, the proper environment, and it will end up here locally. Now this is the case, and I can say, okay, curl localhost hello config, sorry, not localhost, curl this hello greetings hello. And in this case, oh, you already saw it, hello exclamation mark. So what is that? The exclamation mark, of course, comes from my local change here. And I can say that is this hello thingy here. I can change that back to hello or hello question mark. And then, of course, again, my plugin will come. That is just a local environment. But now also my cloud environment says hello question mark, right? Because that cloud environment will be forwarded to my laptop, and then I can immediately, either here or using any other computer, test that setup using the proper cloud gateways, and it will be executed here in my laptop. And that process that is running here can then actually also access the other cloud resources and vice versa. So that kind of becomes a part of that cloud, which of course is far from production safe or anything, but is very helpful for debug or testing purposes. And speaking of debugging, what is also quite helpful, if, for example, you are in a scenario where you don't know what's going on and you don't know why your code is executed that way, might happen sometimes, right, as a developer. So what you can do, either you put in some print statements, right, system out, or what you should do is actually debug, right, using some breakpoints and your IDE features of the IDE of your choice. And in this case, you probably have heard of remote Jvm debugging and probably used it before, right? And this debugging also works with that locally running process because it actually always starts up that server in a debug mode. And what I can do, I can go to IntelliJ in this case and say, oh, dear IntelliJ, please attach to process. This runs on port per default 7777. Now it connects to my local host running process that has been started up using this plugin. And then what I can do, either I go to localhost 9080, or even in this case, I go to my cloud environment and say, oh, hello, and then it will capture this execution, and I'm in my IDE because it has a remote JVM debug that goes to my locally running process that in this case is accessible either via localhost or via this cloud gateway. And then I can debug even in this cloud scenario, see what's going on, why it doesn't work, and then I see the response here using either this local host approach or my cloud setup. So that is very helpful for these environments as well. Or I can run my tests. I can very quickly execute my tests either against localhost or even against my cloud setup and things like that, which are just, let's stop this now again, which are just very, very helpful. So in any way, that is probably the most important takeaways to whatever you do and whatever technology you use, keep your turnaround cycles short. And I mean the turnaround cycles while you are developing. It's okay if the startup of some environment or test environment takes a few seconds or a few minutes, right? So I can come in the morning or at the beginning of my work session, I make some coffee, I talk to colleagues. But then once I come back and that has been started up, then I want to able to work properly, and I want to get into this flow experience of having these fast feedback loops, right? I don't want to wait. I just want to change stuff, see the changes being applied, execute my tests. For the test, it's the same thing. I want to have very quick test cycles. I want to separate, these test life cycles if I have some complex test environment. I started up before, but then it should be running, and it should keep running, so my tests execute quickly as well. So I literally, as you saw, I change code, execute my test, change code, execute test, I immediately get the feedback. And this is very, very efficient, and of course it's also much more fun, right? So these turnaround cycles regard whatever technology you use, typically compilation, then unit testing, which should be quick, then some type of hard deployment, that depends on the technology. So I was using this Open Liberty example, which you can have a look on my blog. I recorded a video how to use this for enterprise Java. I can have a look at the, I will share these resources with you on the GitHub example. That's just one example for Java, but in any way, whatever technology you use, there will be some approach available that you can, script your way around if you have to. Just be pragmatic in this regard while you're developing, and then, well, you will be more productive on that side. And again, this does not really collide with a proper approach of doing CI/CD, of doing continuous delivery, because what you still have to do, you still want to have your proper CI/CD approach of that pipeline that runs once you do a git push. But this whole life cycle is about what you do before you do a git push, right? Before you annoy your coworkers with that build that fails again, right? Because now you're very, very certain that it will work. It's still not the same environment. It still runs your server a little bit differently, right? So there's a non-zero chance that it will behave differently. But the major cases of the obvious errors are definitely covered, where you say, okay, I tested this now locally, running on this cloud setup somewhat, and now I'm pretty sure that it works, and now I can do the git push. I can go to lunch and make some coffee, and then 10 minutes, 20 minutes later, I see the result of my proper CI/CD pipeline, whether it actually works. And that is just an approach that is much more efficient, and I think also much more enjoyable. I hope that was helpful. Thanks a lot for your attention.